Blast off. Okay, so guys, what I'd like to do to get you started is I'd like you to look at the bottom of the lab. So you'll notice that it says calculations, and then you'll notice that there's a balanced equation. Step one of a percent yield process, right? If you don't have a balanced equation, you need one. I've provided it to you. Now guys, look carefully at that balanced equation. Single displacement, double displacement, decomposition, synthesis, or combustion, which one is it? I like that you're stumbling because, guys, the answer is it's none of those. This is not any of the reaction types that you've been familiarized with. You guys understand, when we taught you those 5 reaction types, that was the tip of an enormous iceberg. There are thousands of named reactions out there. Frankly, that's what makes sophomore organic chemistry so awful. In college. But guys, understand this is actually what is called an acid-base reaction. And so as we talk about this being an acid-base reaction, what I'd like to do is I'd like to set the stage for you, and I would strongly encourage you to write this down so that you have this as you're going over to lab. So guys, when we talk about reactions, we know that we have one reactant that's limiting, and then the other we call, if it's not limiting, it's excess. Good for you. All right. So guys, hydrochloric acid will be our excess reactant. There will be a squeeze bottle of hydrochloric acid sitting at your lab table. Guys, it's 1 molar, which means if you get it on you, eventually it'll eat through the oils on your skin and it's going to itch. If you get it in your eyes, you're blind. But if you get it on your skin, it's not really life or death. Run it under water, wash it off with soap. We don't have to drown you in baking soda. It's not that strong. But certainly if you get it on you, you're going to want to wash it off. And if it does get red and itchy, please let me know. And then we will do the baking soda thing. But it's not crazy. Then, guys, your limiting reactant. That will be the sodium bicarbonate. And you will be getting approximately a gram of sodium bicarbonate. But guys, understand, as you know in lab, it's not good enough to be close. So we're going to figure out what the mass of the sodium bicarbonate actually is. You should understand that we're going to do that through mass by difference. But guys, we are going to use about a gram of sodium bicarbonate. That is at the balances at the back of the room. There's a small vial of sodium bicarbonate. It's not dangerous at all. If you spill, please just clean it up. But it's not, you can touch it. Don't, but you can. It's fine. But guys, this is the trick. Do not get less than 1 gram of sodium bicarbonate. You can get more. You don't want 2 grams because it won't fit in the dish. But guys, if you get like 1.1, 1.2, that's fine. You don't want to get less than a gram, because if you get less than a gram, you will actually only have 2 significant digits in your mass, because you won't have this first decimal or the first digit, and you need 3 significant digits in the mass of your sodium bicarbonate. So it's got to be more than a gram. Okay, so then guys, moving along, you understand that we're doing a percent yield thing, right? And so what that means is if we're going to do a percent yield, we need actual and we need theoretical. Let's talk about actual. Guys, in order to get actual, what we need to do is we actually need to weigh one of these products. So guys, picture it. Table salt, carbon dioxide, and water. So guys, when you're done with this reaction, what is your product going to look like? You won't see the salt, because what does salt do in water? It dissolves. Guys, you're going to make carbonated salt water. In theory, you could drink it, but don't, because everything in lab is dirty. But guys, seriously, all you're doing is making carbonated salt water. Now guys, what we got to do a percent yield is we need to weigh one of these. So of the 3, which is going to be the easiest to weigh? The salt, the carbon dioxide, or the water? Because we got to get them apart, right? So let's talk. How do we get rid of the carbon dioxide? It just bubbles away. Guys, the carbon dioxide leaves on its own. So what we're left with then is salt water. How on earth do we separate them? The salt and sand lab, right? Guys, amazingly, we're talking now about something you learned to do in September. Now, guys, if you remember doing the salt and sand lab, you'll remember that we put a cover on the dish. Why did we do that? Because it splatters. So what we're going to do is we're going to weigh a dish with a cover, and then, guys, we're going to boil off the water, and what's left is the salt. And again, through mass by difference, we can figure out the mass of the salt. So this leaves through boiling, and this then becomes our subject product. You guys good? All right. So, guys, with all of that said then, let's zoom back out and let's talk about the lab. So I would encourage you to draw pictures, and frankly, I would encourage you to draw these pictures right there because it's really the only space that you've got. Do it small. So guys, what I'm going to do is I'm going to talk you through the lab. I would encourage you again to write this down. Little pictures. So guys, what you're going to do is this. You are going to start with one of these, which is an evaporating dish. And then you are going to place on the evaporating dish a watch glass, but we understand that we put those concave up so that as the steam condenses on the bottom of the glass, it drips back into the dish and it doesn't run over the sides. What we're going to do then is we're going to weigh it. We're going to weigh both the dish and the lid, and that gives us a starting point from which we can do mass by difference calculations. Then what we're going to do is we're going to take off the lid, and you're going to go over to the balance, and using a weighing boat, you're going to weigh out a little more than 1 gram of sodium bicarbonate. And then you are going to transfer the sodium bicarbonate, which will be more, but approximately 1 gram of sodium bicarbonate. Then guys, what you're going to do is you're actually going to carry out this reaction, and this is what it's going to look like. You are going to add drop by drop, drops of HCl to the sodium bicarbonate. Now guys, when you do that, what you're going to see is fizzing. Go slow. If you squirt, it will fizz over and you're going to have to start over. So it's going to be drop, fizz, drop, fizz, drop, fizz, drop, fizz. And eventually what you're going to end up with is a puddle. Guys, this puddle is a problem. So let's talk about it. So eventually you're going to add enough hydrochloric acid, which is dissolved in water, that you're going to have a pile of sodium bicarbonate at the bottom of your dish, and it's going to be buried under a layer of water and hydrochloric acid. The problem is at that point, the additional hydrochloric acid doesn't touch the baking soda. So once you end up with this little puddle, you're going to stir. You have stirring rods in your drawers, and you're going to stir this. So at this point, what it looks like is maybe one of your lab partners is stirring and the other one is adding sodium bicarbonate, or I'm sorry, hydrochloric acid drop by drop. Now guys, what's going to happen as you stir is the sodium bicarbonate is going to dissolve. And eventually it's going to look like you're adding acid to basically what looks like water, but the sodium bicarbonate's still there, it's just dissolved. So if you can't see it, how are you going to know when the sodium bicarbonate's all gone? And how will you know there's a reaction? The bubbles. So guys, what's going to happen is this. Good for you, Cole. You're going to go drip, fizz, drip, fizz, drip, fizz, drip, no fizz. You're done. That tells you that all the sodium bicarbonate, the limiting reactant, is gone. And if you keep adding HCl, you're just going to muck up your results. So that one drop with no fizz, you're done. Okay? So guys, then at that point, all you've got to do is take this, put the lid back on it, put it on the Bunsen burner, and boil away the water. Once the water's gone, the only thing that's left is the salt. You shut off the Bunsen burner. You let the thing cool down. Remember, how cool does it have to be for you to weigh it? You got to be able to touch it. Even if it feels warm, that's okay. But you got to have it cool enough that you can touch it. Then, guys, at that point, you're going to go weigh it again. And then you are going to rinse everything off. And you're going to put everything back in the drawer. And, guys, they all go in the same spot in your drawer. The dish, the watch glass, and the stirring rods all go in the same place. Put them back where they belong. Come back in here. And then you can start working on your calculations. Good? Okay, so guys, let's do this then. Second. Given everything that we just talked about, guys, now read over the procedure for the lab. Yeah, thank you. Just everything goes down the drain because, I mean, really, if you think about it, the only thing that's left is salt. Yeah, yep. The water's gone, the carbon dioxide's gone. Should just be salt. So guys, that was exactly what I was going to do. Having read over the procedure, what things surprised you? Yeah. Mm-hmm. Is this at the very end when there's just the salt in it? Yeah. Okay. Absolutely, because what you're going to see is that as the water gets more gone, it's going to splatter, right? And the salt, some of the salt is going to be stuck to the bottom of your watch glass. So rather than have to scrape it off, we just weigh the glass at first and then we can subtract. Okay, guys, other things that you need clarification on. Okay, let's do this then. Looking at the bottom of the lab, guys, I'm going to say this once, but I am going to give you some guidance. You are going to calculate the mass of the sodium bicarbonate. Yeah, we know it's about a gram, but you're going to figure out exactly what it is. To do that, we are going to do a mass by difference calculation. Guys, do not do what feels right to you. Do not guess. There is one and only one way to do this calculation properly. Check your notes. Check your salt and sand lab. That was the first time we did this. But guys, there's only one way to do this right. And so make sure that you're doing it right, because if you're doing it the way that feels good to you and it's not right, it's wrong. So the same is true back here. The next thing that you're going to calculate is your actual yield. Also, a mass by difference calculation. Then, guys, at this point, you've got the mass of a reactant, you've got the mass of one of the products. Then, guys, it becomes the homework. You're going to calculate your theoretical yield, you're going to calculate your percent yield. Now, guys, what you're going to see on the test on Wednesday is this. You are going to have this data chart and nothing else. Well, you'll have the balanced equation. Same reaction, but all you're going to have is data. And you are going to, on the back page of the test, do everything you're doing in writing up this lab without any guidance. You get the idea? Okay, then guys, please, looking at the conclusion questions with the understanding that this is going to be well done. We talked about the answers to all of these questions last time in class. Actually, I even highlighted that, hey, this is going to be in your conclusion questions. Guys, there are correct answers to these questions. Don't guess. Make sure that you're doing these well. So guys, these will be due on Wednesday. Before we get into lab, if you don't have your goggles, you're welcome to borrow a pair. Please return them. In addition to that, guys, if during the last few months you have sort of free-formed your groups and you've turned groups of 2 into groups of 11, you're going to go back to where you started. If your group is broken because somebody's not here, or frankly, they've dropped the class, you can reform groups, but we will not have groups bigger than 3, and we will not have more than 5 people at any particular station. Okay, so guys, you got a ton of time. My A-Day class did this in the short day. You have a lot of time. Take your time, move purposefully. When you're done, clean up well, come back here and we'll work on calculations. Go get them.
I found another reaction I want to try. This one doesn't require...
Hold on just one second. Let me stop recording.